problem number 50, we're taking the limit at a finite value, so we're taking the limit at 4 here of this rational function. The first thing you want to do is check to see if when we insert 4 into the numerator and the denominator, do we get out 0? Okay, really we're looking for is whether we get 0 out in the denominator. And the reason that we're looking at that is the numerator is continuous and the denominator is continuous. And so we might be able to just evaluate the function by just taking 4 and plugging it in. However, if we get 0 out in the bottom here, then we have to do a reduction. Okay, so we have to simplify this right here, and we have to come up with an equivalent function. So what I'm going to do is I'm just going to take 4, and I'm going to look at what happened if I plugged it in. So if I plug it into the bottom denominator, I would get 4 squared minus 6 times 4 plus 8. And so that's going to be 16 minus 24 plus 8, or negative 8 plus 8, which is 0. So the issue here is that the denominator is equal to 0 when x is equal to 4. So we can't just do a direct substitution. So what we're going to do is I'm going to take this and I'm going to rewrite it. So let me erase this. I'm going to say, okay, well, we know that this is exactly the same as the limit as x approaches 4. Now what I'm going to do is I'm going to factor, or I'm going to at least try to factor the numerator and the denominator. And so the numerator would factor into x and x, and I'm going to have, I have to look at two things that multiply together to give me 6, but add to give me negative 5. So we're going to do a negative 3 and a negative 2. And then for the denominator, again, x and x. And the odds are it's going to be one of these two. But it looks like negative 4 and negative 2. So I haven't changed anything. In fact, these two guys are equal to one another. And even moreover, these two guys on the inside, these two rational expressions, which are representing functions here, or function, they're equal to one another. Now if we continue, this is equal to the limit as x approaches 4 of x minus 3 over x minus 4. Now here's the important part. This guy right here is not the same as this guy right here. So let me make a note here for you. X minus 3 times x minus 2 over x minus 4 times x minus 2 is not equal to x minus 3 over x minus 4. And here's why. This guy is undefined when x is equal to positive 2. This guy is actually defined when x is equal to positive 2. So this guy can't do anything with it. This guy over here, if I plug in 2, I would get negative 1 over negative 2, so 1/2. Okay, so this is the big idea. This guy right here is not equal to this guy. However, and let me separate this, that's really irrelevant, and here's why. When we're looking at the limit, we're looking at the x values that are close to 4, not the ones actually at 4. And I actually said that wrong. That part... Okay, so let me say this. These guys, exactly what I said is true. This guy is not equal to this guy. Okay? As long as... But they are equal to each other when x is not 2. Okay? Now, if we take a look at the limit as x approaches 4, though, the denominator still gives me 0, but the numerator gives me positive 1. Okay? And if you took a look at the actual function, what you would have, x minus 3, x minus 4, is at positive 4, we have some vertical asymptote. Okay? And so when the x values are more than 4, both these guys are positive. So it would look like this, and on this side it looks like this. Now as we come in at 4 from this side right here, we go towards a positive infinity. As we come into 4 from this side, we go towards negative infinity. So this right here does not exist. Okay, and one of the ways to see that is if you get 0 over 0 when you directly insert, then you should do some reduction. For example, if I plugged in 4 top and bottom over here and I got 0 over 0, then we can reduce and we probably can find a limit. If you get a number over 0, then it's I shouldn't say it's undefined, it does not exist. If you get 0 over a number, then our limit is 0. Okay, so this limit right here doesn't exist because you have this vertical asymptote. Holes in graphs, limit's going to exist. Vertical asymptotes, no.